This Unreal Engine 5.5 actor begins with an orange placeholder cube. Its target sphere exists only as a TSoftObjectPtr path, and the runtime log proves the reference is not resolved before the request. One asynchronous request loads the sphere, replaces the placeholder, and completes once. A second sphere then appears by reading the already resolved soft pointer with 0 additional requests. In this lesson, we will separate asset identity from a loaded object, declare a soft reference, issue RequestAsyncLoad through the FStreamableManager, keep the FStreamableHandle alive, resolve the asset in the completion callback, block duplicate requests with explicit state, reuse the cache, and verify request count, completion count, cache reuse, mesh visibility, and native runtime frames. A hard U object pointer requires a loaded object. A soft object pointer can hold an asset path even when the target is not loaded. That distinction matters when optional characters, cosmetics, maps, large meshes, or content bundles should not all enter memory with the owning object. The demo soft path is engine/basic-shapes/sphere.sphere. Before the request, TSoftObjectPtr returns that identity while is valid as false. The orange cube is a separately loaded placeholder. This proves that knowing which asset you want is not the same as already owning its runtime object. The actor stores TSoftObjectPtr of UStaticMesh as an editable U property. The generic type preserves compile time intent. This path should resolve to a static mesh, not an arbitrary object. The constructor assigns the sphere asset path without using constructor helpers for that sphere. Uses null to detect an empty reference, is valid to detect a currently resolved object, TSoftObjectPtr to request loading, and get only after the object is known to be loaded. Calling synchronous load can be appropriate during controlled setup, but it defeats the non-blocking goal of this example. After a short demonstration delay, begin async load changes state from unresolved to loading, increments request count, converts the soft pointer to an FSoftObject path, and calls RequestAsyncLoad on the asset manager's FStreamableManager. The completion delegate targets handle asset loaded. The actor keeps the returned shared FStreamableHandle. A handle can expose progress, cancellation, combined requests, and release control in larger systems. Here it primarily makes the request lifetime explicit. The state guard allows a request only from unresolved, preventing loading, loaded, or cached reuse from issuing duplicates. When loading completes, the callback calls get on the soft pointer. It validates the returned UStatic mesh, replaces the placeholder mesh, changes state to loaded, increments completion count, updates the color and label, and logs resolved true. Keep gameplay effects that require the asset behind this completion boundary. Code after RequestAsyncLoad runs immediately. It must not assume the object has arrived. Also handle failure and owner destruction in production code. A callback tied to a UObject delegate avoids invoking the member function after its target object is gone. After the first sphere is visible, a timer asks the same soft pointer for its object again. Get now returns the cached static mesh immediately. The demo applies it to a second component, reveals that component, and records one cache reuse. Request count remains exactly 1. This does not mean an asset remains loaded forever. Lifetime depends on strong references, streamable handles, asset manager rules, and garbage collection. The important result is narrower. During this verified run, one asynchronous request resolved the asset, and a second consumer reused that resolved object without another load request. These are genuine game mode frames from the included Unreal project. The first shows unresolved with an orange placeholder cube and the sphere soft path. The second shows loaded with one cyan sphere. The third shows cached reuse with a second purple sphere and the label no request. The frames were captured by Unreal through a scene capture component 2D and texture render target. They are not generated substitutes. Mesh shape, state label, asset path, colors, request log, completion log, and final validation all describe the same runtime chain. The Unreal automation test passed with 1 success and 0 failures. It verifies the exact sphere soft path, default request delay, initial unresolved state, 0 default counts, all 4 state labels, and the rule that only unresolved may issue a request. Loading, loaded, and cached reuse all reject duplicates. The runtime then proves the integration, resolved before request false, request count 1, completion count 1, resolved true, cache reuse count 1, additional requests 0, 3 native captures, visible cached copy, final cached reuse, and valid true. The reusable pattern has 4 steps. Store a typed soft reference. Request its path asynchronously when the content is needed. Resolve and validate the object inside the completion callback. Reuse the loaded object while its lifetime is intentionally maintained. For large projects, centralize asset policy in the asset manager. Use primary asset IDs for managed content, group-related requests, expose progress and cancellation, and define unload ownership. Avoid asynchronous complexity for tiny assets that are always required. But when optional content would create load hitches or inflate memory, this pattern gives AI-generated Unreal C++ a clear and testable loading boundary.